Hello students, now we are going to discuss a question from electric charges and fields, which is an NCERT level based question and it is very important for CBSE. The question is, two insulated charged copper spheres A and B have their centers separated by a distance of 50 centimeters. What is the mutual force of electrostatic repulsion if the charges on each of them is given as 6.5 into 10 to the power of minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation. Also, compare this force with their mutual gravitational attraction if each weighs 0.5 kilograms. Now, first they are asking you to calculate the force of repulsion between the two charges or two charged body spheres of charge 6.5 into 10 to the power of minus 7 coulomb. Now, their radius is to be comparatively taken negligible. First, we will solve this question A and then we will go to question B. So, for this question, solution is for A. So, we know according to Coulomb's law, or first of all, we'll write the data, which is Q1 is equal to, we have Q2 is equal to same charge, which is 6.5 into 10 to the power of minus 7 coulomb. And we have the distance, which is between the two spheres, which is R. I take the distance as, which is equal to 50 centimeters is what we are given with, which is equal to be converted into meters, which is 0.50 meters. So now from Coulomb's law, what do we have from Coulomb's law? Using Coulomb's law. From Coulomb's law, what do we have? From Coulomb's law, we have force between two charged bodies will be equal to 1 by 4 pi epsilon naught into Q1, Q2 divided by the distance square. So we know the value of 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power of 9, and Q1 also we know, which is 6.5 into 10 to the power of minus 7 into 6.5 into 10 to the power of minus 7 whole divided by 0.5 square newtons. This is the force. On simplifying this, we will get F is equal to, on simplifying this, we will get 1.5 into 10 to the power of minus 2 newtons. This is the force of repulsion because these two charges Q1 and Q2 are actually positively charged particles here. So their force of repulsion is what we see between them. So it will be equal to 1.5 into 10 to the power of minus 2 newtons. Now, according to the same case, they are asking you also to calculate the mutual gravitational force of attraction. So the mutual gravitational force of attraction, to calculate that, we know we should have the formula of Newton's law of gravitation. We have one formula there. So mutual gravitational attraction, which is Fg is equal to G into m1 m2 by the radius of the sphere, square of the radius. Oh, sorry, not square of the radius, this is distance, square of the distance. So in this case also, G value is a gravitational constant value, which is 6.67 into 10 to the power of minus 11 into 0.5 into 0.5 divided by square of the distance is 0.5 whole square. So on simplifying this, what we get is the gravitational force of attraction between these two masses is 6.67 into 10 to the power of minus 11 newtons. If you observe both the values of electrostatic force of repulsion and the gravitational force of attraction, we can clearly say that Fg is very less compared to the force of repulsion in air. So now this is the case that they asked in the question A. Now question B also is there. In question B, what are we asked is, what is the force of repulsion if each sphere is charged double the amount and the distance between them is half? So in that case, question B, the sub question 1 is, if Q1 is equal to 2 times of Q, or here in this case, or Q1 dash is equal to 2 times of Q1 and Q2 dash is equal to 2 times of Q2. and the distance is also, I take the distance as r dash, which is equal to q2 dash, and r dash is equal to r by 2, half the distance, and the charges are doubled. In that case, force in air, electrostatic force of repulsion F air dash is equal to k into 2q1 2q2 divided by r by 2 whole square. Now if I simplify this, what I get actually is here, I get it as 2 to 4, 4 16 into k into q1 q2 divided by r square, which is nothing other than this whole value is the value of f, which is already calculated. So substituting that, f air dash is equal to 16 times to 1.5 into 10 to the power of minus 2. This value we already calculated here, the force of repulsion between the two charged particles q1 and q2. So this, on simplifying, you'll get f air is equal to, or air dash is equal to 16 into 1.5 into 10 to the power of minus 2 will give you 0.24 newtons. This is when the charges q1 and q2 are doubled and the distance is halved. There is one more sub question here under this, which is the two spheres are placed in water. If these two spheres, instead of air, if they are placed in water, what will be the force of repulsion between these two bodies? See, there is one simple relation for this as well. In this question, we have a simple relation also, which is a dielectric constant k is equal to, we take it as epsilon m by epsilon naught, or you can also equate it to force in air divided by force in particular or force in a particular medium. So that is water we take here. So that is water here. So I know the value of force in air, that is F value I know. So in that case, what I do is I just take K is equal to force in air divided by force in water. I am supposed to calculate the force that is existing between the charges q1 and q2 when these two are placed in air, placed in water. Now from this I take F water is equal to, force between them in water is equal to force in air divided by the dielectric constant. What is the dielectric constant we have given with 80, and what is the force in air? We know that already, 1.5 into 10 to the power of minus 2 divided by what is the dielectric constant? Air. So force between the two charged spheres when replaced by air, replaced the air with water is, we'll get, on simplifying this, we'll get 1.875 into 10 to the power of minus 4 newtons. So this is the formula. This is the solution for the force in a medium, which is air, of dielectric constant 80. Hope you understood the solution. Follow us on our YouTube channel for more such videos. Thank you.